Hi, welcome guys. So welcome to my Leetcode solving section. So this problem, let's say you are given a network, and then from 1 to n, and you are given times. Okay, so basically this is you can view it as a weight, right? So you have a directed weighted graph. So basically, let's say you start from k, k is your starting point, and you shine some signals, and then you need to return the time for all nodes to receive a signal. If it's possible for all nodes to receive signal, then receive -1. Return -1. So for example, if you put 2, the answer will be 2, right? Because the 4 is the largest node. Okay, so obviously that what is the correct way to solve it, right? This is the shortest path, right? Single source shortest path. So you start from 2, and then you try to get. So you can use a famous Dijkstra algorithm. And I will not. I mean, I already write down. I copy somewhere, right? But it's very good that you remember all these functions and use as a subroutine. Okay. So Dijkstra is a single source. Let's say you put how many node and how many what is the source and what is the graph. Okay. So the first you just create a graph. The problem is that we need to label it from 0 to n-1, right? So for each items, so I use the adjacent list. So for items, actually I0 -1, append I -1, I1 -1, I2. So this is the V, and this is a weight. Okay, so let me just write down. So this is a G of U. Looks like something something which each pair is a tuple. Okay. And this is a V, and the weight of phase UV. Okay, and now you run Dijkstra. So I think the V-exist defined to be false, and you get something max. And for each weight initialized to be max infinity, and this path is just in case that you want to find the shortest path, right? But in this problem we don't. And then there's a Q, and the weights for a source start from 0, and you push, then you pop, and so now this is the subroutine. Okay, you pop the smallest one, and then you check the V is true. If there's some connection edges, then you try to do the relaxation. Okay, so for if not V is V, means that V is not yet V, and you try to relax. So this is try to relax, try to do a relaxation. So you define F to be G plus W, where G is the minimum one. And then if F less than the previous weight, that means we find the shortest one. So, we'll find a shorter one. So weighted V defined with F, and the path V defined with U, and the heat push. Okay. Now return path and weights. Okay, so now you just run this, right? Very simple. Remember that K need to K minus 1. And if the mass, if the infinity is in weight, that means there is some point which is not connect, right? So it's not in the connected component, strong connected component. So return -1. Otherwise, it will return the maximum weight. Okay, so this problem can be solved by just using the simple Dijkstra. Okay, so Dijkstra is a powerful tool. I think you can just use this to solve plenty of the Leetcode problem. Right? So very interesting algorithm. Okay, and very, very important is that only when you relaxate, only when your relaxation step is success, then you push. Okay, so this is the very very tricky part that you only only the non-visited V can have the chance to push, and the second is that if the realization step success, then you push. Okay. And if you using path, then you can find the shortest path. Okay, so this is the Dijkstra. See you guys next videos.